All right, guys, let's do a short review here about relations and functions. A relation is just a collection of paired up input and output values. Okay, so a relation, all functions are relations, but a special type of relation is a function if each input corresponds to exactly one output value. So this is a great example over here of a function, because if I do this vertical line test everywhere, I only get one y value. So each one of those purple lines is an x value, right? So like this one over here is x equals 2, right? And by drawing the vertical line, you're checking to make sure that every time you plug in 2, you only get one output. All right? So yes, this line is a function. Yep. It doesn't like loop back on itself or anything like that. Okay? So the basics of graphing is being able to make a table and plot the points. So you can pick whichever x values you want here, but we tend to do a strategy that gives us at least a decent picture. So I like -1, 0, and 1 if we have nothing to go on, because that typically centers our graph in the middle. Not always, but so when you pick those x values, you have to, those are inputs. You got to plug those in to the equation and you get out what y is. So -1, you plug it in, you multiply it times 3, and you get -3. And we also will plot that on our graph down there. So you always go do the x first and then do the y. 0, 0 is on our graph, and so is 1, 3. So I'll do my best to draw a straight line. We actually only need 2 points to do this, but a third point's kind of nice. So that's the graph. That's it. That's all I'm asking you to do. Now, the next one is taking a half of it. So doing this same arrangement might not be so smart because we're going to get like fractions and stuff. So maybe if we pick -2, 0, and 2, that way when I take half of these numbers, I get nice whole numbers. So I like that a little bit better. So we got -2, -1, we got 0, 0, and we got 2, 1. Ooh, that's not really very good, but there you go. That's a line, right? That's the graph. So there's no correct x values to pick. There really isn't. I just try and pick ones that give us like nice y values, meaning no fractions, no decimals. So what does this number mean? What does the 3 mean, and what does the 1/2 mean out in front? Well, it turns out it's so I wrote down it represents how far to travel up or down for every one move right. So basically what I'm saying is if I go, I'm talking about points that are right next to each other, it's how far I have to go up or down to get to the next point that's just one block over. So that's where the 3 comes from. It's saying I have to go up 3 to go over 1. And for this one, it's saying that to go, like, you have to go up a half to go over 1. So that's, the fractions kind of get pretty gross. But it has something to do like how high we're climbing. But we really just call this slope, right? So this box does a good job of summarizing what slope is. So the slope is the ratio of vertical change over horizontal change. Okay, so we call that sometimes rise over run. So the rise is the vertical, and the run is the horizontal. Okay. So the rise is the change in the y values. It's how far you have to go up or down. So in this case, it's 2. So the rise is 2. It's the difference. It would be 3 minus 1, right? This is 3, this is 1. It's that difference. It's that amount, right? The slope is kind of like directions. Like it tells you to go up a certain amount and over a certain amount, or down maybe. Okay, so the run is the same thing. We have to take, we went from x equals 3 to x equals 5. So the run for this one will be plus 2. So the slope is 2 over 2, which is 1. Okay, so the slope of this diagram here is 1. What's the slope of this line? So there's that table again. Now, when you're doing this, if you're looking here, you should be thinking like, wow, that's kind of gross, right? It doesn't really hit nicely. I have no idea what that value is. So we don't want to draw a point here because we don't know what the y value is. But this one right here, it hits super nice. So I'm going to choose those points, and then I'm going to do my up 2 and over 3. So the slope is the vertical over the horizontal, or the rise over the run, which would be plus 2 over plus 3, which is, of course, just 2/3. So that's a positive slope. It's going up. Okay, what about this one? Again, same sort of, looks like this got stretched a little bit. But same kind of game. We want to find the points that hit really nicely. So I think those two work really well. So we're going to go 1, 2, 3 down. So call that minus. And then over 1. So the slope is m, which is rise over run, which is, in this case, it falls. It's negative. So our slope is negative. And it's steeper, right? If you were like trying to run across this line like this, you would have a really hard time because it's really steep. Whereas this other one, it's not as steep. Like you wouldn't fall down or anything. So that steepness is, it's called the magnitude, the size of the slope. Okay, so those are two positive and negative graphs for you. What about when they want the slope, but they just give you points? Well, we have that other equation, right? x2 minus x1 over, well, hold on, what am I doing? I wanted to label these first. So you label the 1 and the 2 mean like which point it was. Was it the first point or the second point? And that you don't have to, the order doesn't matter. Like you can call the first one the second one, like it's fine, but I tend to label them like this. And then the slope is this equation, right? The change in y over the change in x. So we got 17 minus, so actually before I start shoving stuff in, I like to write down this nice little template for us so we don't have to think as much about the negatives. 17 is y2, 1 is y1, and we have 3 is x2, and negative 5 is x1. So doing a little bit of math for you, the slope is 2. So that little template really helps me because I always forget like this negative sign. So I'm going to use it again over here. So first label x and a y, x and a y. the slope is the formula. We'll write down our little template for things. So y2 is 6, y1 is 2, x2 is 7, and x1 is minus 5. This is 4, and this is 12. So the slope is a third, so not very steep. All right, great. That's a key skill. So the y-intercept is the y value of a point that intersects the y-axis. Okay, so this is the key form, the slope-intercept form. You've seen this before, I know you have. Y equals mx plus b. Okay, so why is b the y-intercept is a good question, right? Because like whenever we see an equation, we have to graph it. We're going to list this right away. Well, actually, we'll write this as like this. But we keep using that. We keep saying, oh, b is the y-intercept. And I'm sure you've heard it before. Maybe you've asked why. Well, what happens when x is 0? Don't we plug in 0 for x? And look, we get y is 2. So when this is 0 right here, this tick mark, it's 0. Okay? And it's saying that when you plug in 0, you get 2. So whatever number's out here, or whatever number's right here, that's the y-intercept, because when you plug in 0 for x, the whole front part just goes away. It's just 0. Okay, so that's a little bit of why is this number out there, the y-intercept. Because when you plug in 0, that's what you get. You know, and that's the y-intercept, is when x is 0. All right, so you can do these ones pretty fast, right? Because we know it gives us everything. It tells us the slope. It tells us what b is. Okay, because that's the form. Slope and the y-intercept. So I always do this first. So I'll put the b here, and then I'll go down 2 and over 3. And then just like that, that's a pretty good line. So it's seriously nothing more than that. So again, over here, slope is 4, which is very steep. I'm going to write it as a fraction, and then b is minus 2. So we're going to go 1, 2, 3, 4, 1, 2, 3, 4, and then over 1. So that would be that line, okay? So y-intercept first, and then you do the slope. You count the slope. It's directions. It tells you where to go. Go up 4 and over 1. Okay. Over here, I'm going to just divide this whole thing by 10 because I want y by itself. Okay, but 5 over 10 is just a half. So dividing all 3 of those by 10, you know, that's what we're going to get. And then we see what the slope is. We see what the y-intercept is. Go to the y-intercept first, and then follow the directions. M says to go, remember this is vertical over horizontal. So go up 1, and then over 2. Positive slope, pretty slight, but it's there. All right, and then they ask you, what's the equation of this line? So in order to write the equation, all we really have right now is y equals mx plus b. So we have to locate what b is, which in this case it's what? It's 2. And then we have to find the slope, but we already practiced this. So I'm going to scan for a point that hits the grid nicely. So this one hits nicely. So we go down 3. 1, 2, 3, 4. So we down 3 and over 4. So remember, it's rise over run. So we got to do the vertical and the horizontal. And then bam, that's it. Negative slope. Okay? And then real quick, these are real fast here. Vertical and horizontal lines. So when I say y is 3, I'm telling you that no matter what x value you pick, if you pick 2, if you pick -4, if you pick 0, no matter what you pick, y is at 4 or at 3. Okay? So it's a horizontal line. Y is fixed at 3. And it's kind of the same thing here, is if you pick x to be -5, it's stuck there. It can go up and down, but it's a vertical line. Okay? So sometimes you can, this is what helps me remember, is if we had a 0 slope line, it would have m, right? Y equals mx plus b. It would have m as 0. No slope, 0. And that actually gets you, if we work this way, we get there. So a 0 slope equation is y equals a number. So this is a horizontal. And the slope of this line is just straight up 0. So that helps me keep them straight. Y equals a number is a slope 0 line. Over here, though, this line is a vertical line. And the slope, imagine if you were, like, you can imagine yourself as a stick figure walking across this, right? But that is not even possible when it's a vertical line like that. Again, no ladders. You have to run across it. It's impossible. So the slope, it doesn't exist. You could also see the slope called infinity. But we tend to say this most often. The slope just doesn't exist. It goes up, but it never goes over. So there's no denominator, and that's a big problem. You can't have a 0 in the denominator. So real fast, let me wrap these two up. So if you want the slope here, if you want the slope of a line that passes through these 2 points, we better set up our template, and we better do some labeling. Notice I label those the same every time, and then I need to plug in y2, y1, x2, x1. Whoa, and then we get a pretty bad problem here. Right, guys? Like, we're dividing by 0. So that doesn't exist. And if you're curious why, if we go to 2 and go to -1 and 5, guys, we're talking about a vertical line. Okay? Slope doesn't exist there. So this just simply just does not exist. So this one here, this is kind of what I talked about before. If you have a 0 slope line, this is of the form y equals a number, right? It's a flat line. But where should it be? Well, this is x and this is y. So if we maybe draw a quick picture, 1, 2, 3, 4, 5. If it's a flat line, it better be, it's not this, right? It's this. So what is that equation? Well, we went down to -2, didn't we? So the answer is just y equals -2. all right? So again, that's a horizontal line, has a slope of 0, all right? You got plenty of practice to do. I think you guys will be fine. Good luck. You can always find me if you need me, all right?